Today we're going to talk about the surface areas of pyramids and cones. Like we've talked about before, the surface area of pyramids and cones is really just a set of problems that takes all of the pieces and puts them together. And so when we look at these pyramids here, we need to understand certain vocabulary that goes along with them. As you can see, I have two hexagonal pyramids here. One of them is upright and one of them is slanted. And so this is going to be a regular pyramid. And we're going to call this a non-regular pyramid. And the faces are really still the same. And so what we have here, we have the lateral faces. And that's everything but the bases. Okay, the lateral faces are the triangles that make up the point that go to the point, and the point, of course, is called the vertex. Okay, and when it's upright, we're going to call this the altitude or the height, the altitude or the height, and this blue part over here is going to be the slant height, because it's the slanted side of that pyramid, and that's going to be the slant height. Okay, and so when we look down here, we really have a square pyramid, but the principles that we're going to go with are going to be applied to all pyramids in general. In order to find the lateral area, it's going to be just the triangles, and so it's the number of sides times the triangle. Okay, so we're going to have 1/2 of this side times L, which is the slant height, times the number of triangles. So this is the area of the triangle times the number of triangles. The surface area is going to be all this. So 1/2 S times L, which is the area of this triangle, times the number of triangles, plus the area of the base. So the area of the triangle sides plus area of base. Okay, so that's all there is to it. It's finding the area of shapes that we already know how to find the area of. And so when I look down here in example A, really I have a hexagonal pyramid, but it's really just 6 triangles and a hexagon. Okay, so if I find the lateral area, it's going to be equal to area of the triangle times the number of triangles. So let's find the area of the triangle. That's 1/2 base times height equals 1/2 of the side length times the slant height, because that triangle has a slant height. And so when I substitute this in, it's 1/2 4 times 7, which gives me 2 times 7, which is 14 meters squared. Well, 14 times 6 gives me the area of all of them together, so that's 60 plus 24, or 84 meters squared. And so the lateral area is this 84 meters squared. Well, the only thing I need to do to find the surface area is add this hexagon at the bottom, and so if I draw this little hexagon in, and I figure out that this is 4, and like we always do, we divide this up, and then I'm going to pull out this triangle. So I divide it in half. This is 2, and I'll pull one of these out. So I've got 2. This is the apothem. I don't know the length of this, but that's okay because it doesn't matter, because this is going to be 60 degrees. So that means this will be 30 degrees. And so A over 2, or 2, I'm going to set up my trig ratio here. So the tangent of 30 equals opposite over adjacent, so 2 over a, like we always do. We'll multiply by a on both sides, so a tangent 30 equals 2. So I'll divide by tangent of 30 on both sides. A equals 2 over tangent 30. And so what I end up with is the area of the base is equal to 1/2 apothem 2 over tangent 30 times the perimeter, which is 4, 4, 4, 4, 4, 24. So this is 24 over tangent 30. And so my surface area equals 84 plus 24 over tangent of 30, which really gives me, I've got it written down here, 125.6 centimeters meters squared. Okay, so that's my total area. Let me check my work here. 125.6 meters squared. Area of all the sides plus the area of the base. See if you can try this one on your own. Notice I've given you the slant height. I've also given you the side length of that pentagon there. Okay, so see if you can try that one on your own. Let's talk about cones for a minute. Cones are a little bit different, but much the same. In a cone, really what we have is we have the radius of the base, and we still have a slant height. Okay? This is called a right cone because if I draw in this height here, it's a right angle to the bottom, and this is called an oblique cone. It's got that slight tilt to it. Okay? The vertices are still these top points here, okay, where it comes to a point. And this is called the axis. In this one, the axis is going to be this tilted, okay? And these circles are called the bases because it's just a circle. Somewhere I saw that it was called a circular pyramid. I don't know. It's called a cone. And this is still slant height. Okay? And so to find the area of a cone, it's really just finding the area of the lateral face and adding the area of the base. Well, if we look at how this works, this is really the radius, and this is L. And this is a net diagram of a cone. And how that relates is this is the L, so this is the slant height, and the radius is going to be inside this circle. Well, to find the area of a cone, the lateral area is going to be equal to pi times radius times the slant height. Okay? And the surface area is going to be equal to L plus B, or pi RL plus pi R squared. Okay? Lateral surface area, pi times radius times slant height. Base is pi R squared because it's a circle. Okay? So when we look at this, really all this is just figuring out what the pieces are and plugging them in. So lateral surface area, or lateral area, is equal to pi times radius times L. Well, what do I have? I know pi, that stays the same. My radius is 5. I don't know my L, but notice what I've got here. I have a right triangle that has 5 and 12, and so if this is L, 12 squared plus 5 squared is equal to L squared. 144 plus 25 equals L squared. So 169 equals L squared. So L must be equal to 13. Okay, I just used Pythagorean theorem on this right triangle. So pi times radius times L is pi times 5 times 13. Gives me 50 plus 15 is 65 pi. Okay, so my slant height is 13, so that makes my lateral area 65 pi. Well, if I have 65 pi and the area of the base is pi times radius squared, well, that's pi times 5 squared equals 25 pi. So my surface area equals 65 pi plus 25 pi equals 90 pi feet squared. That's all there is to it, guys. It's a process of finding each individual piece and putting them all together. Okay? See if you can try this example on your own. This represents the whole diameter of this circle, so there's one little extra step in there. All right, guys, thanks for watching. We'll see you next time.